All right, welcome. This is the Unit 7 test review. So it's covering radicals, special right triangles, Pythagorean theorem, all that good stuff we've been learning. So the first part, simplifying radicals. Okay, we've got these first three problems here. They're adding and subtracting. So remember, if you've got a radical there, if they have the same radical, you can add them. If there's something without a radical, well, then you can't add it to something with a radical. Okay, and if you have to simplify, then you got to do that first. So the first one here, we have 3 root 6 and 8 root 6, so that's 11 root 6 plus 7. Okay, and the order on this doesn't matter. You could do 7 plus 11 root 6. It's the same thing. All right, here we go. We have a 13 root 5 and a 28 root 5. So if you do 28 plus 13, that's 41 square root 5. And then we have minus 13. So there we go. Here, 3 root 6. And then we have minus 8 root 6. So 3 minus 8, that's negative 5 square root 6. And then minus 7. All right. On these, we have to distribute, okay? So we're going to have this 4 square root 5 multiplied to both of these terms in here. So 4 square root 5 times square root 5 ends up becoming 4 times 5, which is 20, okay? And then this 4 square root 5 times the negative square root of 125, well, you can actually multiply that, okay? So you can do, it'll be negative 4 times the square root, and if you do 125 times 5, you get 625, because remember, you multiply the numbers inside that square root. And then, so we have negative 4 times, and then 625. See if you can do the square root of it. Type that in. Oh, it's a perfect square. The square root of 625 is 25. So we have negative 4 times 25, so that's negative 100. So we have 20 minus 100, so we get negative 80. Okay, the next one, we have 3 square root 10 multiplied by root 10 plus root 40. So 3 square root 10 times square root 10, that's 3 times 10, because square root 10 times square root 10 is 10 times 3, so that's 30, plus, now we have 3 square root, okay, you have to do 10 times 40, so that's 400, and the square root of 400, okay, square root of 400 there is 20. So we have 30 plus 3 times 20, so 30 plus 60, 90. Okay, next one. All right, so 2 root 6 times root 6 is going to end up being 2 times 6. So this is 12, okay, minus. And now, actually, we're going to look here. Square root 36 is 6. So we have 2 square root 6 times 6. So this just ends up being 12 square root 6. All right. Now these are dividing, okay, so there will probably be some rationalizing going on here. First thing, when you have one big square root inside this, like one big fraction inside the square root, make sure you simplify first. So this is the square root, and 28 and 36 can both be divided by 4. So that's 7 over 9. And then this is the square root of 7 over the square root of 9. Square root 7 is just square root 7. The square root of 9 is 3. So it's square root 7 over 3. Okay, this one here, we're going to simplify square root 32 first. So we have 3 times, and if you factor 32, you get 2 to the 5th, so that's 5 2s. So we have two pairs that are going to come out, so 2 times 2. So 4 is going to come out. So we have 4, then we have the square root 2, still over 16. And then you look for common factors. Up here we have 4 on top, 16 on bottom. They can both be divided by 4. So 3 square root 2 over 4. And that's it. Okay, now this one we have 28 over 12 square roots of 8. Simplify that square root 8. So you have 28 on top. And then we have 12 times, and 8 is 2 to the power of 3. So we take a pair of 2's out, so we get a 2. And you have 1 2 left back in there. So what we can do is we can actually see here, you know, 12 times 2. So you have 28 over 24 square root 2. And then you can look and see 28 and 24, you can divide both of them by 4. So we get 7 over 6 square root 2. But then remember we have the square root 2 in the bottom, so we have to rationalize. So you have to multiply by square root 2 over square root 2. So we have 7 square root 2 over 6 times 2, so 12. So there we go. All right, next part here. On these ones, it says find the height of, or find the length of each altitude. The altitude is this part here in the center. Okay, and you have to pay attention to the angles. On this one, we have the altitude here. This is a 60, and this is a 90 on this side, so this means this is a 30. Okay, and over here also this is a 30. So this is an equilateral triangle. Remember, if you take an equilateral triangle and you draw the altitude in it, you've created two 30, 60, 90 triangles. So they give us the hypotenuse, and we need to find the altitude. So that's the longer leg here. So first step is to go from the hypotenuse to the short leg, so divide by 2, so this is 6. And then to find the altitude, you just take your short leg, 6, and you put the square root of 3 on it. So there we go. Okay, for this one, we have a 45, 45, 90. Okay, so 45, 45, 90. So that means these are 45 up here. And again, they've given us the hypotenuse, and we need to find one of the legs. So remember, to go from the hypotenuse to the leg, you take the hypotenuse and you divide by the square root 2. So we've got to rationalize here. So you have 12 root 2 over 2. So we get 6 root 2. And that's our altitude, because the two legs of your 45, 45, 90 are congruent. All right, next one. Again, we have a 30, 60, 90. The 12 is the hypotenuse. This time our altitude is the shorter side. So all we have to do is take our hypotenuse and divide by 2, and our altitude will be 6. All right, next group of questions here. It says find X, Y, K, and M. All right. Just take a look at what we got here. We see this on the left-hand side. This is a 30, 60, 90. On the right-hand side, this is a 45, 45, 90. So right away, on the 45, 45, 90, I know that the two legs are congruent. So M is 6. So right away, M is 6. And now I can figure out Y. It's going to be 6 square root 2. So 6 square root 2. And now all I have to do is figure out K and X. All right, they've given me the short side, so my job is pretty easy here. To get the longer side of my 30, 60, 90, it's just the short side with a square root 3 on it. So 6 square root 3, that's K. And then X, the hypotenuse, is just taking the short side and multiplying by 2, so 12. Okay, it says find the length of the side of a square whose diagonal measures 20. So we have our square, and our diagonal is 20, and so we need to find the side lengths here. So when you have a square and you cut it on the diagonal, you make a 45, 45, 90. So your hypotenuse is 20, so you have to divide it by the square root of 2 to get the leg. And then we rationalize. So you get 20 root 2 over 2. So it's 10 square root 2. So that's the length of each side of your square. Find the length of a side of an equilateral triangle whose altitude measures 27. Okay, so here's an equilateral triangle. This is the altitude, it's 27. When you take an equilateral triangle and you cut it in half on its altitude like this, you're creating a 30, 60, 90 triangle because all three angles are 60. And so then you cut it in half, so it makes a 30 and a 30 up here. And this one down there is 60. So the 27, the altitude, is across from that 60-degree angle, so that's our longer side. The hypotenuse is functioning as a whole side of our equilateral triangle. So if I know my long side, I can find my shorter side, which will get me to my hypotenuse. So to find the short side, I'll take 27 and I will divide it by square root 3. I got a square root in the bottom, so I have to rationalize. So I get 27 square root 3 over 3, which is 9 square root 3. And so that's the short side. And now to get the hypotenuse, which is the length of one whole side of our equilateral triangle, I just have to do times 2. So 2 times 9 square root 3 is 18 square root 3. Okay, next part. I'm going to let you guys do 5 on your own there. 6, I'll kind of help walk you through it here. So the first thing we need to look at, we need to understand what kind of things we have going on here. You have to see there's 3 triangles here. We have this obtuse one here, okay? But we're not really concerned with that one at the moment. Then we have this small right triangle here, okay? There's a right triangle, but we need to figure out what these angles are in these corners. So this 135, that can make a straight line. So you do 180 minus 135, and that'll give you 45. So if this is 45, that means this one up here is 45. So we have a 45, 45, 90 triangle. And then also you need to look at the big picture. Okay, we have the big triangle. It's a right triangle because we have this right angle here. And then look at this angle. It's 30. So it's a 30, 60, 90. So we have a 45, 45, 90 here and a 30, 60, 90 going on. Now they do tell us that MR, so from here to here, they tell us that this part is 6. So on your 30, 60, 90, that's your hypotenuse. So now let's find the short side. Well, hypotenuse, we just divide by 2, so our short side is 3. So RQ is 3. Now, that's one of the legs of my 45, 45, 90. So QP is also 3. And that's QP. Now, I can find RP, or PR, whatever you want to call it, because 45, 45, 90. So this is 3 square root 2. Let's see, do we need that? Yep, we do. So it's 3 square root 2. And then the last part we need is MP. So we have to look at the big picture here. We have a 30, 60, 90 big triangle. And we know the short side here. So MP is this small part right here. In order to get that small part, I need to figure out the big side and then take off this piece QP that I know. So if the short side of my big 30, 60, 90 is 3, then I know that the whole side of it is going to be 3 square root 3. So just to find MP, this little piece here, I'm going to take 3 square root 3 and take away 3 because that's the piece that I don't need. And really, this is as simple as it's going to get. So 3 square root 3 minus 3. Okay. Okay, well, look here. They tell us BC is 8 square root 3. Okay, again, you've got to see here, we have 2 different triangles going on. We have this 30, 60, 90 here. Okay, and we know it's a 30, 60, 90 because they tell us 30 here. We have a 90, so that means that this part's got to be 60. And then, now look, that 60 is part of a bigger angle. This bigger angle here is 90. So if this is 60, then this part's 30. So I have a second 30, 60, 90. So here's another 30, 60, 90. So now you know the hypotenuse of the bigger one. You can use it to help you find the altitude and this bigger leg there and the other pieces. All right, number 8. It says find x. Okay, well, x is over here. It's the long side of this 30, 60, 90. So in order to find the long side, I need to know the short side. And the short side of this happens to be the hypotenuse of this 45, 45, 90. So they tell me the leg. So to go from the leg to the hypotenuse, I just multiply by square root 2. So it's 5 square root 2 right here. And now to go from the short leg to the long leg, I have to take 5 square root 2 and multiply it by square root 3. So it becomes 5 square root 6. And that's x. Okay, on these ones it says classify the triangle by its side lengths. So you have to do a squared plus b squared, and then you calculate c squared on its own, and you see which one is bigger. So first off, try to calculate here. See what 5 square root 5 is. Well, it's 11.18 something. So that is our c. Okay, so we're going to do 5 squared plus 10 squared. So this is 25 plus 100, so 125. And then you have 5 square root 5 squared. So it's 5 square root 5 times 5 square root 5. 5 times 5 is 25. Square root 5 times square root 5 is 5. And so 25 times 5 is 125. Well, they are equal, so that means this is a right triangle. Okay, on number 11, I'll just kind of help you set this up. It says JG is the altitude to the base of FH of equilateral triangle JFH. Okay, equilateral triangle. JG is the altitude. And the base is FH. Okay, so your altitude's making a right angle here, and it's an equilateral triangle. So that makes 30, 60, 90s. And FJ is 15, and then I want you to find JG. So I'll set you up a picture there. And of course, I'll have the answer key posted online. Number 12, Corinne walks around a square horse run. Okay, square area there. If one lap is 400 feet, what is the length from corner to corner along the diagonal? Okay, 400 feet for the whole lap here. So I need to know what one side is. So 400 divided by 4, each side is 100 feet. So this is a 45, 45, 90. So my hypotenuse is going to be 100 square root 2. And that's the distance across the diagonal. All right, next one's here. on this one. On 13, 14, they don't tell us if these are 30, 60, 90 or 45, 45, 90s. So what we do when we don't know any angles, we have to use Pythagorean theorem. Okay? So a squared plus b squared equals c squared. So here's our c, this is our a. So I'm trying to find b. So I can do c squared minus a squared equals b squared. And to get b, I would take the square root of both sides. So I'm going to do this all like in one step. So if I do the square root of c squared, so 2 square root 53, put that all in parentheses, okay, square that, minus, you got to do a squared, so 14 squared, that's going to be equal to b, okay, because I did the square root already. So now, go through here, 2 square root 53 squared, it's 2 square root 53 times 2 square root 53. So basically you take the number in front and you square it, so we get 4. And then you multiply it by the number inside the square root. So do 4 times 53, which is 212. So you have the square root of 212 minus, and 14 squared is 196. So now do 212 minus 196. So we have the square root of 16. And so what's the square root of 16? 4. So B is 4. And number 14, same way. Okay, 15. It says the length of the short leg of a 30, 60, 90 is 6 square root 3. So just draw here. So this is 6 square root 3. Find the lengths of the hypotenuse and the long leg. Okay, long leg, just multiply this by 2, so you get 12 square root 3. And then to get the longer leg, you do 6 square root 3 times square root 3. So this becomes 6 times 3 is 18. All right, number 16, they're just asking you to find the hypotenuse, so they're asking you to find C. They give you A and B, so find C. Pythagorean theorem on that one. 17, a tree was hit by lightning during a storm, cracked and fell over. The height of the broken tree is 8 feet, so this is 8. The tip of the tree touches 15 feet from the trunk. What was the height of the original tree before it broke? So to find the original tree height, we have to do the 8 plus however long this broken piece is. So the first thing is to find that. So we can do a squared plus b squared, and that'll give us c squared. So c squared is 8 squared plus 15 squared. So we have 64 plus 225, which is 289. So C is equal to the square root of 289. And so try it. Try the square root of 289. And what do you get? 17. So this broken piece is 17. So to find the original height, you have to take the broken piece and add the part that's still standing. Add 8 to it, and you get 25. So the tree was originally 25 feet tall. Okay, on 18, I'm going to help set you up. This is a Pythagorean theorem problem. You're finding SD, so you're finding your A or your B, whatever you want to call it. Here, they give you one radius, it's 200 feet. Now, we also have this other one. PF, this is another radius, it's also 200 feet. So to find your C, you have to take the two pieces and add them. So 200 plus 250 is 450. So that's your C. And call this 200 your A, and you're finding your B. So just use Pythagorean theorem to find that one. Okay, number 19. Again, this is a 30, 60, 90. They've given us the longer side, so we just have to divide by square root 3. So you have square root 15 over 5. Remember, to divide by square root 3, you're really going to multiply by 1 over square root 3. It's that keep, change, flip. Okay, so we have square root 15 over 5 square root 3. I noticed 15 and 3, they have a common factor there, so you can divide that. So 15 divided by 3 is 5, so we have square root 5 on top, and we still have 5 on the bottom. So it's square root 5 over 5 for the short side. And then to get the longer side, just multiply that by 2. So it's 2 square root 5 over 5. All right. 45, 45, 90 triangle with a hypotenuse of 28. Find each leg. Well, how do you go from hypotenuse to the leg? You're going to divide by square root 2. So we do 28. Divide by square root 2. We got square root in the bottom, so we have to rationalize. So we get 28 square root 2 over 2. Well, 28 and 2, you can divide that, so you get 14 square root 2. Okay, number 21, I'm not going to do that one with you guys. 22, y'all have got that one. Okay, 23, again, this is very easy. Just divide by square root 2 and find which one of these is going to match. 24, pretty simple. Find your short side first, then go to the longer side. 26, yeah, that's very straightforward. So is 25. Okay, 27, just be careful, they say find the length of xz. So they tell you that angle y is 60 over here. So that makes this a 30, 60, 90. So this part up here is 30. And we can see this is a 90-degree angle, so that makes this part over here 60. So if you want to find xz, you're going to use this 30, 60, 90 triangle right there. And so here we have the 48, that's our short side. We need the longer side, so it's just 48 square root 3. Okay, and then number 28, the length of the short leg of a 30, 60, 90 is 30. So this is 30. And it says find the area of the triangle, so we have to know our base and our height. So if the short leg is 30, the longer leg is 30 square root 3. So now we just have to do base times height, divide by 2. So 30 times 30 square root 3, divide by 2. So do 30 times 30, that's 900 square root 3 over 2. So it's 450 square root 3. All right. So like I said, I'm going to fill in the rest of the answers with the work so you can see it, and then I will post the key. And so good luck, and see you on test day.